I hope you remember that logistic regression is a classification problem. That simply means using this regression, we would like to classify something either as yes or no, or in binary, we can say either 1 or 0. For example, an email can be classified as spam or not spam. So only two categories are possible in logistic regression. Or maybe you are predicting a patient has cancer or not. Or maybe in sales, you are predicting if a consumer is going to churn or not. So see that in every case, we have either 1 or 0. So in these type of problems, we can apply logistic regression, and of course in regression like linear regression, we can find out which of our predictors or independent variables are significant in terms of predicting that binary outcome. All right, so we can do that also similar to our linear regression. We can do that in KNIME. So let's go and build a linear regression, logistic regression, and find out using the same Airbnb dataset that we used before from Asheville. Let's find out what are the factors that significantly predict or affect our binary outcome. And we will select one of the binary outcomes or variables that are available, and we'll build a model, run the model, and then we will look into the output, regression output, and also discuss a little bit how to interpret that output. Let's go to KNIME and we continue from there. All right, so to start, we can simply click on create new workflow. I created one right here. This is a blank interface at this moment, or you can say a canvas, right? A blank canvas. I'm going to call it canvas because we are going to put things there, draw our model, and this is how we can build a model. So let's start with our usual Excel reader or CSV reader because we need the data first. Let's drag it from here. I'm under notes, and then under notes we have this CSV reader, and if you don't have it, you can search here as CSV reader like before, and you can find it right here. Drag it here, leave it, simply leave it, and then now use this one, use configure. This will give you the option to select the data, select browse, go to wherever your that data is. I have my data under document and under ID 565603. Go to data, select Asheville. So whatever data set you have, you can select that one. Click. You can look into the columns that are available and the variables. Both are the same thing. So I'm going to interchangeably refer to either variable or feature or column. All mean the same thing. Columns in terms of Microsoft Excel. Click apply, click OK. Now we have the data. If you click the play button here, it is going to run the node and read our data. Put a comment, read data. Next what? So like before, we can check for null values to see if we have any empty cell or not, any empty row for any column, and apply and continue. Search for remove null values. So as the suggestion says, find for missing value and simply drag it here. Connect these two nodes. It is going to now be connected to our original data set that we just read using our CSV reader. Let's configure. It easily doesn't need to do anything, but as I showed you earlier, that if you want to remove, then simply go here, select remove row. This is going to remove any row that has missing value. Click apply, click OK, run it again, and now if you have any missing value, this step is going to take care of that one. Going to simply remove the null row or the row that has null value. So you can say remove row for NA. All right, now what? We can now go to our logistic regression, or we can simply do one more step to remove any column that has zero variance. So you can say remove zero variance columns. I find it convenient because usually we don't remember, and we don't need to remember all the names for all the nodes, right? So we can simply use our Kai and get the suggestion for our nodes from here. All right, so drag it again, low variance filter. It is going to remove any column or variable that has extremely low variance or zero variance. Connect these two, configure, and now you can see basically it shows that the variance upper bound, keep it default like this. Remove if you don't want any of these columns from here that you want to remove and exclude, then you can do it. Drag, select, and you can exclude this one using these buttons here. Click apply, click OK. Let's run this one, and now we have the yellow shows no columns were filtered out, as the statement shows. That means there were no columns that has zero variance. So we did not really remove anything, but you usually or most often you will find that there will be one or two columns that did not have that much variance or zero variance. So you can sometimes filter out that one. All right, put a comment again with zero bar. Let's now build our logistic regression. Search for, let's go to nodes, search for logistic, and now we have our logistic regression predictor. Remember that we are not really predicting anything. So usually you will find one predictor and one learner. At this moment we need a learner only and not a predictor. So click and drag the learner here, and now we have the learner available. So simply connect it to the learner, the previous step, get the data from here. Let's click configure. The most important part is to determine which one is your dependent or target column. At this moment we have the superhost as. That means either someone is superhost or not, and the reference category can be superhost or not superhost. This is going to be automatically selected. This is kind of like a binary column that the model creates based on your reference column or your original column. All right, so I don't really need to do anything here. Let's just remove this one because this is exactly same as superhost as, only superhost as is in a string form that says the letter or word superhost or not superhost, and this is the binary form 1 or 0 based on the same column, so we don't need this one. Other than this, all the other columns are important to determine if someone is a superhost or not based on the Airbnb dataset that we have been using. So we are going to keep those here. Click apply, click OK. Let's again execute and run this cell. Click here, and now if you see a yellow marker like this, you can keep your mouse there, cursor there, and read the statement. The statement says it did not reach the convergence after the specified number of epochs. It's fine. You can increase the epoch and see if it improves your model or not, but for now we are going to just keep it like this. All right, so we are done with our logistic regression, done with running our model and finding our output. Simply right click, select open output port, go to right here that says under coefficients and statistics, click table. Give it a second. Take a look at that table here. Now, of course, because it did not reach the convergence, so it does not show you the p-value or the the coefficients. I'm sorry, p-value or other standard error and c-square and all those things. So only shows you the coefficients. As I said, it is possible based on your data set. If your data set is small, then it's possible that it might not reach the convergence. So let's do one more thing. configure. Instead of this one, let's um, use the non-superhost to see if it makes any difference or not. Remember that we are still excluding our superhost n because this is the same one. Click apply, click OK. Let's run it again and check out that table. And it should be pretty similar, and it's exactly the same because it doesn't, as I mentioned earlier, it doesn't really matter because our initial column is the reference column superhost s, and based on this one the reference one was created, so it's fine. Let's you can run with a different data set to see if that one give you any different output from a different city. I collected it from Asheville, you can collect it from, let's say, New York, from LA, from anywhere else, and try it out and see if your result is different than mine. But this is exactly how you run a logistic regression, and based on this output table, now you can see which one is significant or not, or which one has how much effect on your binary outcome or predicting your binary outcome. In our future lectures, we are going to also build a predictive model using this logistic regression, and that will be a little bit more than what we just did. So right now we have the learner and we stopped here just for regression. For making our predictive model, we will also bring a logistic regression predictor, and then we can build our predictive model. In a different lecture, I'm going to show that. For now, we will stop here. So I hope this is helpful. Please reach out if you have any questions. Thank you.